Let's talk about our inverse trig functions. The three standard trig functions that we work with, sine, cosine, and tangent, have definitions where the sine of theta, cosine of theta, and tangent of theta are all proportions or ratios of different parts of a right triangle. So sine is the opposite over the hypotenuse. Cosine of theta would be the adjacent over the hypotenuse, and tangent of theta would be the opposite over the adjacent side. Now, what inverse trig functions are be written like this. And these are also called the arc functions, or this would be also known as arc sine. This would be known as arc cosine, and this would be known as arc tangent. And the way that they work is they undo the trig functions. So if sine of theta is opposite over hypotenuse, arc sine opposite over hypotenuse is equal to theta. If cosine theta is equal to adjacent over hypotenuse, arc cosine of adjacent over hypotenuse is equal to theta. If tangent theta is equal to opposite over adjacent, arc tangent of opposite over adjacent is equal to theta. Think about how doing division undoes multiplication, or doing subtraction undoes division. Doing these inverse trig functions, arc sine, arc cosine, arc tangent, undo sine, cosine, and tangent respectively. So what does this look like whenever we are doing a problem with them? If I have something like the arc sine of 1 over 2, well, this means the sine of some unknown is equal to 1 over 2, and we are trying to figure out what this unknown would be. Referencing our unit circle, we would know that the sine of pi over 6 is equal to 1/2. Therefore, arc sine of 1/2 would be equal to pi over 6, because arc sine undoes the sine function. So if the sine of pi over 6 is 1/2, the arc sine of 1/2 is pi over 6. So let's take a look at an example with arc cosine. Remember, arc cosine undoes the cosine function. So whenever we are given something like arc cosine of negative root 3 over 2, we can think about it as cosine of theta is equal to negative root 3 over 2. So, referencing our unit circle, what angle would give us this value? Well, we know that the cosine of 5 pi over 6 would give us negative root 3 over 2. So this means that the arc cosine of negative root 3 over 2 must be equal to 5 pi over 6. Because remember, arc cosine is just undoing what the cosine function did. Let's look at what it looks like to combine a couple of these trig functions. Let's start with arc sine of cosine pi over 2. To solve this out, first we need to figure out what cosine pi over 2 is. And the cosine pi over 2 is 0. So now we're asked, what is the arc sine of 0? In other words, if I take the sine of some unknown, when will it be 0? And the most obvious answer is arc sine of 0 would be 0, because the sine of 0 is 0, so undoing it would still give us a 0. What about something like the sine of arc cosine of 2 over 7? So this one's interesting because we are given arc cosine of a ratio. This can be rewritten as saying the cosine of theta is equal to 2 over 7. Knowing that, let's set up a triangle that makes sense this way. So we'll set up a right triangle. We'll call this angle theta. And the cosine of that angle is 2 over 7. Since cosine is adjacent over hypotenuse, this side must be 7, and this side must be 2, and the hypotenuse must be 7. Next, let's find this missing value. Using the Pythagorean theorem, we have 2 squared plus x squared is equal to 7 squared. This would be 4 plus x squared is equal to 49. Subtract 4 from both sides, x squared is equal to 45. So x must be plus or minus 45. We're working with a distance. Distance is always positive, so we're going to say that positive 45 or positive root 45 is our x value. So we'll put that in on our triangle. Square root 45. Now, the reason that's important is because when we are given a value inside of arc cosine, it will spit out theta, or it will spit out the actual measurement of that angle. In this case, we don't need to know exactly what it is. We just need to know that arc cosine of 2 over 7 means that the cosine of theta, some unknown angle, is 2 over 7. Knowing that, we need the sine of this value here, and this value is theta. So we need the sine of theta. That means that we are going to do sine is equal to opposite over hypotenuse. So we are going to have the sine is equal to root 45 over 2. And that is the answer for all of this mess up here. It's going to be root 45 over 2. Let's take a look at one more. We have sine of arc cosine of x over the interval -1 to 1. So the reason this interval is important is arc cosine is only defined over -1 to +1. I'm going to solve this one out two different ways. I'm going to solve it with trig identities, and I'm going to solve it with a triangle. So let's do the triangle version first. Arc cosine of x means that theta is the same thing as, the cosine of theta is equal to x. X can be described as x over 1. Everything is always over 1. So on a triangle, that means our hypotenuse would be 1, and our adjacent side would be x. Let's solve out for this unknown side here. That would be x squared plus our unknown squared is equal to 1. Subtract that from both sides and square root it. That means this side is going to be equal to the square root of 1 minus x squared. Now, arc cosine of x is giving us back theta. Then we want the sine of theta. So the sine of theta is opposite over hypotenuse, which will be root 1 minus x squared over 1. And since anything over 1 can be expressed as itself, that means we have root 1 minus x squared as the final answer for this problem. Now let's take a look at what this looks like working through it as trig functions, or trig identities, I should say. We're going to use the Pythagorean trig identity. And if you don't remember it, it is sine squared plus cosine squared is equal to 1. Now, the reason that this is important is we're going to say arc cosine of x is equal to theta. That's the first step. That to be in yellow. Arc cosine of x is equal to theta. Now we also know from our Pythagorean identity that sine of theta is equal to the square root of 1 minus cosine theta. Finally, since we know arc sine of x is equal to theta, this means that the cosine of theta is equal to x. Because remember, these are inverses of each other, they undo each other. With all of this information in place, let's start plugging things in. We can have the sine of theta, because arc cosine of x is equal to theta. And so we're going to turn this entire arc cosine of x into theta. Then we can turn sine of theta into the square root of 1 minus cosine, this should be squared, of theta. And we know cosine of theta is x, so cosine squared of theta would be x squared, meaning that our final answer would be 1 minus, or root of 1 minus x squared. And we can see that with trig identities, we got the same answer as we did whenever we did this working through a triangle. And that's all I've got for you today. If you found this to be helpful, consider liking and subscribing. If you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.